Okay. Hello, everyone. So I'm Adam Blanchard from 4265, and I'm the design lead. So, so we're going to be talking about kind of some of our experiences, or what some of our experiences were being or doing a swerve drive for the first time. Um, and then also showing off and kind of revealing some of the design and parts for a new swerve drive that we've been making, which is a 2-speed shifting swerve drive. So that's what we'll be doing. So how we kind of started with Swerve was last off season, we decided we wanted to try and build a Swerve, and we wanted something that we knew would work, and that we could also do pretty quickly. So we didn't want to completely design from scratch our own Swerve drive, and this turned out to be a very good idea. So instead, to get the experience, we decided to machine 2910's Mark II modules. So all of the parts for the modules that we made were actually machined in shop. So we got a lot of experience with machining and really kind of learned how all of the parts work together and what made their swerve drive so good. The modification, or the only modification we made, were to the wheel mounts, and we found these 5-inch pneumatic wheels that we put in, which turned out to be a very good decision because this season they definitely came in handy, going through the center of the field and over the bars. So that was the only modification we made, and this worked really well for us. We had something up and running relatively quickly. I think we actually finished and got the robot, a test bed robot with 4 modules running, like at midnight New Year's Day, like 4 days before build season started. So that was a bit stressful, but we at least had all the code working, and we had enough experience that we felt comfortable going into the season with the option of using a swerve drive, which is exactly what we did. So going on from that point, I think since kind of the beginning of kind of building the swerve drive, machining it, we were kind of always trying to piece together some way to put a shifter in it, mostly because our team has always run shifters, and we thought, and especially at the beginning of the season where we were kind of trying to decide which drivetrain we wanted to do, swerve or tank, one of the biggest deciding factors was whether or not we could have a shifter so that we could still be confident around defense and also have that kind of extra speed of a tank drive. So we wound up going with Swerve, but of course we still want to be able to have a shifter. So we've developed this model. So this has gone through, I think, 3 versions now. And I can talk a little bit about kind of how we transitioned and what we learned from 2910's modules and how it's applied here. And I'm sure it's very clear where the inspiration is. In fact, most of the parts in here, specifically the main pulley and pretty much everything below the plate, is all directly from our previous modules. So the main reason I did this and why I wanted to try and do that, and this was actually one of the biggest considerations when I was designing the module, was kind of machinability and being able to get a functional prototype up and running quickly, because I knew that like in the coming off season or whatever, um, I didn't want there to be such a large barrier to entry for us to actually prototyping one of these modules, because we already have something that works, and I didn't want us to spend forever pursuing something that might not work. So that actually turned out really well. The original, if I so there was a few different versions of these. Like this version 2, which you'll see. Here we go. So this was one of the earlier versions, and this was kind of one of the more difficult to machine models, just because we had to machine the actual shifter. Yeah, this was definitely a much earlier version. I was still kind of in testing phase of playing around with stuff. But this originally we were trying to use a dog shifter because, and this actually comes into how the gear stacks are aligned. Um, if you see in the version that we're currently making, the Falcon actually has two pinions stacked on top of each other. And in order to get the spread that we wanted, this is actually a hex adapter. And then we put a 20-tooth gear on it. So we can get over a 2-time spread, while still keeping everything on one Falcon shaft. So before we kind of figured out that we could do that, and we were still trying to use Neos, we had to machine a hex actually into the top of a dog shifter. And then the actual gear stack that would do the shifting was on kind of this intermediate shaft, which could have led to all kinds of problems. It was definitely not a perfect design, because you could have all sorts of kind of axial loads on the shaft that we didn't want. So that was one of the major jumps that kind of moved this from an idea to something that we actually really wanted to make. So this is a much more feasible design. Same with this shifter. Or the shifter piston. Before, it was actually mounted on this plate above the motors. And then, but because we had to change this and make these pinions, and the motors all moved in, we didn't have room for it in the center of the module. So this linkage was another big stepping stone to getting to something that could actually be manufactured and made in real life. But those are some of the new things. Some of the things that we kind of learned from our previous set of modules and our experience over the season and that are implemented here are, one of the biggest ones is the encoder. So on the Mark II module, which I can pull up here, it's actually a set of gears with the absolute encoder. And we didn't have too many problems with it, although in competition at least. In our earlier testing phases, because the gears were all 3D printed, and the encoder, like the hub that went on the encoder shaft just had like a set screw in it. There was nothing actually positively keeping it together. So here we've used, it's a lamprey encoder, which uses a magnet, and that's how it picks up its rotation. So there's no mechanical connection between these two parts, and we've almost completely avoided putting load on any sort of 3D printed parts. So this is a 3D printed kind of adapter that attaches to the pulley, similar to the Mark II, but here it's just holding the magnet and it's using that to find its position. And it's still absolute and everything, so we still maintain that, which is very good. I guess, some of the hmm, yeah, yeah, some of the challenges, that's a good point that we had. Um, with the previous module, I mean, definitely one of them was actually the machining of it. Um, I think our first modules came together pretty well. We didn't have too much trouble kind of reusing um, the 2910s CAD and all of that kind of stuff. Um, with the actual, I think the biggest challenge with actually designing this module was just figuring out how to package everything in a way that was realistic and that could actually fit kind of in the same space as the Mark II modules. Because another big design consideration in this was it being kind of a hot spot with our current modules, so we could test them really easily and they'd be compatible with our current robots. So this is a completely drop-in replacement. Um, but just figuring out kind of like this using the Falcon shaft and putting two gears on it was a big step, and then kind of figuring out how the shifter would actually package. The reason why we went with a ball shifter, um, I know a lot of teams use the dog shifters. We've always used ball shifters just because we felt like they're a little more reliable because you don't have like gears kind of meshing and stuff. So that's why we use the ball shifter. It is a little heavier and it's actually less compact, but that's kind of what we're willing to do to get a ball shifter in here. But yeah, yeah, I can talk about speeds. I didn't ever get the graphs pulled up, but yeah, if you could. Um, yeah, so one of the, let's see, so the speeds for this module were actually, well, there was a lot of thought that was actually put into the speeds because we didn't want to we wanted something that would be fast and would also give us kind of the ability to still push stuff around. I think one of the biggest considerations in all of this and why we're so excited to do this is because we can have a swerve drive that can push people around and we can be a defense spot even though we're a swerve drive. So kind of having that sweet spot of maneuverability and pushing power was a big inspiration for all of us. So we're trying to pull up the, give me a sec.
You looking for it?
Yeah,
I've got it pulled up over there. I just need a flash drive it over.
it'll load. I have the graphs and stuff. Yeah. So I don't have the gears loaded in here. But this will be fine. Yeah, that's fine. Zoom has decided. So the so a question is, has the module actually been machined? So we meant to have the module fully assembled today, but we didn't really hit that deadline. Most of the parts are machined, so we'll be able to run some tests probably later this week or next week sometime. But we have the main plate machine and the motor plate machine. So there's a little bit more work, but we're in the process of actually building it right now and getting the working prototype running. And I could show off some of the parts because it's kind of interesting to see them in real life. Just give me a second. Oh, that's true. You guys can't see them, but let's see. Here that is. Let's see. Where is it? It's called new drive circuit. Um, we're trying to pull up the speeds, but do you have them set up in the other thing? Like the actual there. And maybe this transfer frames. Oh, sure. We can talk a little bit about why we're using the pneumatic wheels. So yeah, one of the things, or one of the major design changes from 2910's modules, they use 4-inch just traction wheels. So we found these 5-inch, they're actually Nordic skate wheels. So they're 5-inch pneumatic tires. There's a few reasons we wanted these. For one, we can swap in 4-inch wheels, just the same wheels 2910 uses, if we wanted to. So it's just nothing really changes, but this gives us a lot of advantages. One is, of course, going over obstacles and stuff like this here, going over the center bars, which was helpful. There's a few others. One is, I think the pneumatic wheels generally have better traction, and they can give the whole swerve drive frame a little bit of movement, so that if any of the modules are slightly off or not mounted perfectly, it has a bit of play so that we make sure all 4 wheels are always in contact with the ground. That way our steering doesn't go whack or anything. So just overall consistency in steering and that kind of stuff. Yeah. Yeah. Yeah, I guess another reason we like kind of the swerve drive as well is that so we can, let's see, if I can pull up the full robot, which I might be able to do without crashing the computer. So the modules are really easy to swap in and out. So if something breaks, it's or one of the module breaks, we can just swap a new module in, and same with the wheels, they're really easy to drop in and out. Um, but yeah, other than that, we can open up to discussion and Q&A. That would be good, I think, for people to ask questions. So, a question from chat, which is my question is whose idea was this? So I can talk a little bit. So from the beginning of like us trying to do a swerve drive, again, like one of the biggest reasons we were hesitant for doing a swerve drive was we kind of lost the ability to have two speeds, which we're very familiar with running. So it was kind of always a plan or a desire to have one of these modules. It's been in development for around a year, actually. So yeah, pretty much when we started building our first swerves. Um, yeah, it was a mixture of kind of going through iterations just in CAD and trying to piece together some of like the fundamental linkages, and I had to really kind of take apart the whole modules in my head and figure out what needed to be there, um, and what could sort of change and move around, and how we could fit a shifter in there somehow. So there was definitely a lot of thought that went into it and a lot of banging my head against the wall because it took a while. And there was a few kind of waves of inspiration that eventually got to this point. I think I have an inspiration folder. Yeah, so this was a module I found on Chief Delphi. It was it was an idea for, or I guess a concept for a shifting swerve module. I just found it randomly as a new post, and it had the kind of shifter linkage here because at this point I had figured out that we really wanted to use a ball shifter, and here you can see a lot of inspiration was taken from this, using the Falcon with two pinions as well as having the shifter piston. And I took some of these ideas and kind of applied to them to what I was already working on. So kind of packaging it within the Mark II kind of space, and yeah, kind of fitting it to our machining standards and all of that stuff.
Yeah, and if you didn't brag enough, this was a project led and basically done entirely by Adam up until the end. It was more of a free time project throughout the
Yeah, that's true. It was pretty much me just messing around and trying to figure out something cool.
So, and this is, I'm just amazed myself that this ever came to be. But it's a really cool product, and we're excited to be hoping to use it next year, when we in the 2021 year. By the way, I am Mac Patrick. I am now an alumni, but I was the team captain for 4265 last year in 2020. So I guess I could also talk about last year at we competed at the Rock City Regional in week 2, right before everything got shut down for coronavirus. And yeah, in Arkansas, Little Rock, Arkansas. And so we were running our non-shifting version with the pneumatic tires. And the pneumatic tires were a huge help in the game this year. At least we felt so. We noticed a lot of other teams breaking modules and whatnot, but the pneumatic tires are great. If you ever want to go back and take a look at any of our videos on the Blue Alliance, you'll see us flying across the bars, doing the spin tricks. The clearance is really nice too. That was a nice benefit for this. We've got good clearance just over the bumpers to go over the railings, and we don't have any issues running over the balls. So it's definitely been a nice module for our team. Yeah.
They're nice and easy to swap out too.
So our frame for next year and for this year.
Pull this monstrosity up. So this is our full robot, or at least what it is in CAD. So our frame is very simple. It's just a 1x2, 30x30 frame. So all of our modules can just be swapped out. So that was one of the biggest parts of this, was being able to quickly swap out the modules in case something breaks. So another question is, how'd build season go? What are you most looking forward to with the potential of the 2021 season? So build season I think it was very different than last year. And we did a lot more prototyping and kind of quick iterations on our robot. Last year, we kind of designed stuff and we had prototypes, but pretty much it kind of got thrown together on the robot and it turned out pretty well, surprisingly. But this year, we kind of designed from the beginning with the idea of modularity and keeping everything super easy to swap out and super simple. And I think that's going to really pay dividends in the future of this robot, because we can change stuff out so easily and everything is so modular. So, okay. So the next season, I think personally, I'm really just looking forward to seeing how far teams are able to take the robots with so much extra time. So kind of seeing how competition evolves as the game is really played through and really analyzed. And it'll be interesting to see how much is different between kind of this game and previous years, seeing that all of the teams have so much time to kind of develop their robots and their strategy and how they play. Another question is, what are the reductions at each level, and what's the difference in real robot speed between shifts? So I will, because I don't have the sheet pulled up with all of the reductions and stuff. Yeah, but I mean, I have it pulled up, but it just doesn't have the right gearings plugged into it.
Even the one I gave you?
I don't think so. Because that one was all there. Yeah, I know that. But I'll probably, once we have the actual prototype done and we can get some video of it running, I'll probably throw something up on Cheap Delphi that goes through all the specifics and some more detailed pictures and stuff and explanations on actual numbers and what all the gearings are. As far as the difference in actual robot speed. So it's geared so that the in quote real speed, um, or the free speed, I think is 9 feet per second low and about 23 high. So in reality, it'll be about 7.5 feet per second low and then around 22 feet per second high. So it's pretty close to a 3x spread. Um, so why shifting? So I've been like trying to convince myself that shifting and doing this is worth it just because with the Falcons and brushless motors, there's actually a lot of question as to whether or not shifting is really viable, or at least useful. Personally, the main reason why I think this is helpful is just being able to accelerate faster and being comfortable with gearing super high and not browning out whenever you hit something um, at those super high gearings. So um, those are kind of the advantages of shifting. And again, we've pretty much always been a shifting team or a team that really like to run shifters. Um, I think further, we recently, like last year, I think was not a good year to do, well, last year, I say last year, I guess 2019 would be an example of a year where you would not want to run a shifter, because you're always running short sprints and you're kind of always on a half side of the field. But this year, because it's a full field game and speed is such a um, kind of crucial part of this whole game and cycle times, I think shifting will be definitely something that's going to kind of separate us from a lot of the other Swerve teams on the field and really give us an advantage when the competition will be so hard.
And to butt in, last year, as in 2020, our game that we found at Rock City was cycling full field without the shifter. A lot of teams, you'll see them staying on the near side. And maybe it was because our shooter just wasn't dialed in enough yet. But we found that the full field runs were really what we excelled at. So that's what we were doing most of the time. Now, if you were to say a team that's mostly staying in your side of the field, just running from that side feeder station and the overflow and putting as many balls up as possible, again, it's shorter sprints. The shifting is probably not that valuable. But for us, this was, we felt, a good choice for a next step and a way to improve our robot going in next year. So
yeah. Another thing that I'm kind of interested in this year, because with a tank drive, you lose a lot of speed whenever you're turning and kind of making adjustments and stuff. I'm curious how the shifting is going to affect and like being able to have a really high geared robot is going to work with the Swerve because you're always maintaining your momentum and you're never really changing direction. Um, you're going to have a lot more time to accelerate instead of always turning and all of that stuff. Um, when you're kind of shifting between a really low and a really high gearing. Yeah. So those are kind of the advantages we hope to have. And I think this would be hard to kind of justify in a lot of other games, but this year it seems almost perfect for it, just because we are running full field and we do want the maneuverability and all of those things. So we will definitely be hopefully running it this season as long as we have the weight. we won't really know the weight for sure until we um, kind of build it and compare it to our current modules. But um, it, I think pretty much all of the weight is purely in kind of the shifter and the extra gears that go into it, just because it's packaged pretty much the same way. But yeah. Let's see. So to clarify, we have not run these modules on a robot yet. So this is just a prototype we're building right now. So we don't have any experience running these, but we're hoping that we'll be able to see a fairly large difference between cycle times running these modules and running our older modules. So what azimuth bearing and bevel gears are you using? Where did you get them? And what parts are they machined? So pretty much the entire azimuth side of the module has not changed from the Mark II. So the gears, the pinion, the shaft has just been kind of extended, and the pulleys and all of the ratios are the exact same as the Mark II, which you can definitely see over here. So the bevel gears are all the same, and same with the bearings. Let's see. This shaft is machined in-house, so it's a custom part. Everything else, you can find these bevel gears and all of the bearings on the Swerve Drive Specialties website. So we have the machine that we use to make it. So we have two CNC machines, we have a CNC router, a 4x4 Laguna. I don't know the exact specifications. I'm sure Mac will go grab these. Also, we have a Tormach CNC mill. I think it's a 4000 series, but I'm not sure exactly what machine it is. But those are the machines that we use to make it. Mac will give me specifics.
So the Laguna, to be specific, if anyone's wondering, the Laguna is what we cut all of the plate stuff on. It is a Laguna IQ 4x4. And the Tormach we have is a Tormach B440. So any of the more complicated parts you see here, like the pulley, the wheel mounts, and the shaft, those are machined on the Tormach. During the season last year, we were also able to send out a decent portion of these parts to machining sponsors. So we made everything here first, and then we sent them out to the machining sponsors. Just for simplicity, because this stuff takes a lot of time, specifically some of the more complicated parts like wheel mounts and pulleys.
Yeah.
So we're very thankful to have those sponsors.
Yeah. So some of the other inspirations. So I showed the other module. I don't remember what team this was from. I think that was someone's kind of just summer project that they were trying to do, similar to kind of how I came up with this. Some of the earlier iterations were inspired by, I think it was, I don't remember. It was I know the name, it was called the Hermes module. That was the name of the Swerve module. I think it was, I don't remember what team it was, but yeah. So there wasn't the inspiration was mostly drawn from kind of our own experiences as well as the Mark II, and then kind of bits and pieces of what I've seen from kind of successful other swerves on Jeep Delphi. Um, so 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 a question is, what would you say to teams looking to do Swerve after doing it for a year? So I'd say one of the biggest things is really making sure you understand not only like the mechanical parts of the Swerve, but also how all of the kind of the components that go into driving one and the software side, because it's especially before, I'd never recommend trying to build a Swerve and run one during a build season. I'd always say, no matter what, try and build a full test bed with 4 working modules that you can test code on um, in the off season before you try and commit, just so that you're comfortable and you really have to see the capabilities of the kind of the Swerve base yourself before you commit to it in competition. Because once you've committed, it is very different than trying to run a tank. And that kind of leads into this next question.
Well, I'd like to also
Oh,
tag on there to emphasize you can have the best swerve drive out there, but a swerve is only as good as the coders and the code behind
that's very true.
And if you have an inexperienced level team in the code, I would be very careful in how you approach it. In previous years, we've considered going into swerves, but our coding team just wasn't developed enough up until this year. So when it was my first couple of years, we'd have one guy on a laptop, and we'd sit in the shop for 8 or 10 hours in a day, and just sit there and watch him code as we all sit there, just hanging out. But that's just not viable for a swerve. You really need a developed coding team who can back up to get all the math behind it and calculations into it.
Yeah, this math is vectors, so a strong math background is good to have to understand. It took us about a couple weeks just to figure out the math, and then another couple weeks just to make sure we could code that little tiny section.
Yeah. So I'll answer this. So a COT swerve versus making your own from scratch. So this kind of goes into what I said just before. Buying a swerve, it kind of depends on your machining capabilities, because I know a lot of teams don't have the same capabilities we have machining stuff in shop. I think if you want something working quickly, and you think your programming team can handle it, I think COTS option isn't horrible. However, it is probably, well, I guess the bomb doesn't exist anymore, so that's not really a factor. But the experience you gain from kind of machining it yourself and kind of taking the entire module apart in your head is really valuable to understanding how it works and how to actually fit it onto your robot and making sure that you're kind of using it effectively. So I think if you have the machining capabilities, it is definitely a good idea to try and machine it yourself. Otherwise, the COTS options aren't bad at all. So let's see, how did you design the rest of your robot to fit your swerve style? So it's kind of interesting because it really depended kind of on our game analysis, especially since we um, haven't had much experience with the Swerve before. So we, from the very beginning, we kind of pieced apart the two kind of different play styles that we could have. And well, really, it kind of comes down to being a tall or a low ball. So being able to go under the control panel or not. And we thought that our main game would be trying to cycle quickly to the front of the trench and make our shots from there. And this is still kind of our goal. What we have in mind for kind of our game we want to play. So, like having a shooter that can make shots consistently from the trench, which we don't have right now. But also kind of being able to make those sprints as short and as fast as possible. Um, so as far as the rest of the robot, I can pull up the full robot here. So that is true. The intake is hidden. So, there we go. So the kind of other part that came with that is just cycling as fast as possible. So one of the biggest parts of our robot is the hopper. So being able to quickly grab balls from the kind of the feeder station. I don't even know what it's called this year. I just call it the feeder station.
Loading station.
Loading station. I don't know. It's all the
Same
same. But yeah, being able to kind of line up really easily with it with the swerve and really get balls fast and being able to make those cycle times faster and faster was a big consideration in this robot. A lot of other design choices on a robot came from having kind of a lack of motors, because one of the things that I think a lot of teams don't consider, or at least don't consider enough when they're trying to run a swerve, is how much it limits you from a motor perspective. So, like a few other things, I guess, like our tower and our climber are driven with a PTO from the same motor. So, kind of this.
It's still showing this work
Um,
model.
yeah. But our kind of our tower that feeds the balls up to the shooter is driven with the same motor that drives the climber. So the complexity of running a swerve drive isn't just the swerve drive, it's being able to kind of implement systems that can maximize your usage of motors, um, and being able to make custom gearboxes and those kind of things if you really want to be competitive and run all of the things that you need to kind of complete every aspect of the game effectively. Yeah, you can see, I guess it's showing a 775, but also our kind of our belt, or what we call the V belt, but what's feeding the balls from the hopper is actually run with a bag motor, so that we can have two of them with only using one PDP slot, and the other one, although we don't have it on the robot right now or design, hopefully can be used to spin the control panel. So kind of using motors like that and all of those things kind of come along with using a swerve drive. Um, so someone asked what sensors. So if you look up Lamprey Absolute Encoder on Cheap Delphi, it'll probably pop up. Otherwise, I'll be making a post on Cheap Delphi with some of the specifics, and I can make sure to include that as well, as far as like an actual link to where you can buy them. This is a good question for you, Alex. What does the math behind your swerve look like?
We use vectors and wow, it's been a year since I did this. What we got it working, so we don't have to go back to it. I'm actually trying to post a link to our GitHub right now in the chat. I don't know if it worked. I can't tell, my Twitch stream on my phone isn't loading, but it was a lot of vectors. So if you know physics, you can do it. And I think there was some trig involved too. Sorry, I'm not very specific. It's just been a while.
Yeah, there are a lot of resources from other teams as well on how to design kind of the Swerve framework for actual like control. I think there's stuff that you can download as well, as far as just like having a full Swerve drive thing. But I think our team pretty much built one from scratch just because we wanted an easy way for it to implement into the rest of the robot code, which was also important for us.
I believe
We use a lot of stuff from Chief Delphi to get it started, but then we made our own code.
we have at least what our code was like in December before the start of the season. I believe that's on Chief Delphi somewhere. If you look up like 4365 code dump or something,
Yeah.
you might be able to sort through all the garbage there.
It's named Swerve Math, so it's, if you can find the file itself, it's relatively easy to find after that. And the GitHub link may or may not be in the chat. It's still loading, but our GitHub is 4265 Secret City Wildbots, I think, and it's available there.
Is that, do you have code for the shifting stuff?
We don't have a shifting.
No, I'm just wondering if like that's been fixed.
Yeah, so kind of the implementation of this is also, we I think was last year the first time we used auto shifters in code.
Yes.
Yeah, so last year
2020.
2019, last year was, so we use auto shifter code that will just kind of read the motor speed and will automatically shift for the driver. I think the biggest implementation of that, or kind of the biggest thing to note in the implementation of that, is allowing the driver to always shift and break the code whenever they want. But that's another thing, is a very, from a driver's perspective at least, a very helpful thing to have, especially when you're trying to maximize cycle times. Something to not have to really focus on is shifting between low and high gear. So that's another kind of code implementation we plan to make.
We had auto targeting with the Swerve, so there was coordinate positioning or transforming, and we mapped the location of our robot using our line light and swerve odometry on the robot, so it knew where it was. That let us use field oriented, so that the robot, if we told it to drive straight down the field and we turned while doing it, it would still drive straight down the field.
Yeah, that was another big code thing, is having kind of field oriented control of the robot. So like if you're just controlling it and you're kind of controlling it from the perspective of the robot, if you like spin, your forward is no longer kind of the driver's forward, and you can lose track of what the front of the robot is really quickly. So that's another big thing to consider if you're looking at doing a swerve. Being able to set up that code is also a big part of it. But I think we're about out of time. So that'll be all of the questions, I suppose. Um, Otherwise, look for a Chief Delphi post in the coming week or so, where you can see module in real life, probably running, hopefully running.
Also, if you have any questions that are more urgent or whatever, you can email us at 4265.business@gmail.com.
That's true.
Right.
And Alex should be able to drop that in the chat.
But other than that, I think we're done. So thank you for listening, and I guess good luck to all you teams out in 2021.
Good work.